semester. What is trigonometry? If we're going to study this thing, we ought to know what it is that we're studying. Who wants to take a stab at it? We're not going to write the paper this time because this is much easier than last time. What is trigonometry? Come on, let's use some good word analysis here. What is trigonometry? Anything in here you know? Tri, right? What does tri mean?
Three.
All right, so we got some meaning there.
Three-dimensional.
It has something to do with,
Triangles.
yeah, it has something to do with actually trigons. Let's think back to geometry.
Shapes.
Polygons, right? Polynomial is algebra. Polygon is a closed figure, right? And it's something simple, closed
Angles.
figure. Convex. Yes, it's a simple, closed, convex figure. Simple meaning none of the lines cross over each other. Closed meaning it's not open. It does all the sides come together and meet. But a trigon is then a three-sided polygon, which we call a triangle, right? A trigon is a triangle. Now, what does ometry mean? Metry. What comes to mind? Measure, right? So trigonometry is all about measuring. Oh no, my stylus is not working. Measuring triangles. Let's see if I can find one that works. Trigonometry is all about measuring triangles. Now, we use triangles in all different sorts of life here. Gosh, I got to remember how to use this stuff. Erase all strokes. So it is the measurement of triangles, or the measuring of triangles. All of trigonometry deals with triangles. Okay, so we're going to really dig into it. Incidentally, geometry, geo is, what's geography? What's geography? Geography. Graphing or mapping the world. Geometry is measuring the world. So measuring the world is what you're learning in geometry, how things interact in space. How do we measure things? Distances, sides of triangles. Trigonometry is a very specific subset of geometry. All right? So we're measuring triangles all through this course, and there's going to be a lot of different applications to the measurements of triangles as we move through this. Okay, so if geometry is the measurement of triangles, what's the next logical question? Today's very basic lesson. What's the next logical question? What is a triangle? Thank you. A triangle is a polygon with three sides and three angles. Okay? Triangle is a polygon with three sides and three angles. Very basic. Again, what is a polygon? It's a closed, convex, and simple figure, right? It's closed. What does that mean? Not open. Convex, what does that mean? Convex is the opposite of what? It's the opposite of concave, right? A concave figure, guys, would look like this. You know, if we had something pointing toward the inside, you know, this particular vertex of this triangle is pointing to the inside, or that's not a triangle. It's not anything really. It's just a figure. It's pointing to the inside of the object. That is concave, and that is not a polygon. All right. Polygons have to be convex, which means all of the vertices of the figure are pointing outwards. All right? And it is also simple. Okay? Simple means none of the sides can cross each other. This particular figure that I just drew here is not a simple figure. The sides cross each other, and therefore it's not a polygon. All right, so a polygon is a closed, convex, simple figure. I don't know if you got really that specific in geometry or not, but so a triangle is a three-sided polygon, also has three angles. All right, what's an angle? What is an angle, right? If I didn't have the definition up there, it would be a little bit difficult to talk about what an angle is, right? An angle is the space within two lines, line segments, or rays. It can also be thought of as the rotation between two line segments or rays. Right? So if we have two line segments, if we have a line segment here and a line segment there, this rotation, that space, how much rotation occurs between those two line segments is the angle. Okay? And we can classify angles three ways. Who remembers the three classifications for angles? Acute. What is an acute angle? Acute angles are angles whose measure is less than 90 degrees and greater than 0 degrees. And yes, you can have negative angles. We're going to talk about that Friday. Okay? An angle whose measure is between 0 and 90 degrees is an acute angle. All right? What's the other? That's triangle. That's a triangle classification. A right angle that measures 90 degrees, and an obtuse angle is an angle whose measure is between 90 and 180. All right? We've got to make sure that we don't go past 180. If we go past 180 degrees, which you can, we're outside of our normal classification of angles. An angle whose measure is between 90 and 180 degrees is an obtuse angle. Okay? Now, why just these three classifications? Why don't we have a classification for angles that are bigger than 180 degrees? You haven't thought about it?
It would just be the reverse side of it. Like if you flipped it over, it'd just be the inside of the opposite one.
Okay. Okay. I see what you're saying. I like the way you're thinking. It's not the correct answer, but it's a good answer. Why do we not classify angles that are bigger than 180 degrees? What's the biggest an angle can be in a triangle? Have to be less than 180, right? You couldn't have an angle that's bigger than 180 degrees. You couldn't have an angle that's equal to 180 degrees. Every angle of a triangle has to be either acute, right, or obtuse, right? Or it wouldn't be a triangle. Because basic triangle facts, and this is not even a fact we're going to mention, I'm going to assume you know that the three angles of a triangle add up to be 180 degrees, the triangle sum theorem. Okay? Now, so we're really not interested in angles bigger than 180 having a classification because they're not angles of a triangle. What is trigonometry? It's the study or measurement of triangles. Right? Now, we're going to talk about angles that are bigger than 180 degrees, but we're going to do that in the context of triangles. And that's, again, a few days away from us. Reference angles is what that's called. But obtuse angles are angles whose measure is between 180 degrees. I don't think it's on here. We mentioned already that right angle is an angle whose measure is equal to 90 degrees. What is a 180 degree angle called? A line is also called a straight angle. Okay, straight angle is another classification, but again, not one that we're that interested in geometry, in trigonometry, because you can't have a 180 degree angle in a triangle. All right? Now, supplementary angles are what? Who remembers the definition? Two angles whose sum is 180 degrees. That's exactly right. So supplementary angles this is a concept that's going to be important for us in trigonometry. Two angles that add up to be 180. What's the other special angle pairs? Y'all remember it? Complementary angles, correct? From geometry, complementary angles, a pair of angles whose degree measures have a sum of 90 degrees. This concept is going to be extremely important in trigonometry, complementary angles. All right, you guys are familiar with the word sine, right? What else are you familiar with? What does that bring to mind? Cosine. Now, sine and cosine, that prefix co comes from complementary. Okay? They're complementary functions. And what that means is that they assign equal values to complementary angles. The sine of 30 degrees is equal to the cosine of the complement of 30 degrees, 60. Sine of 30 equals cosine of 60. Sine of 20 equals cosine of 20, and 70 are coangles, complementary angles. So sine of 20 equals the cosine of 70. All right? And we'll kind of do that. Incidentally, by, tomorrow, you need to have a calculator with you every day. And you can use whatever calculator you want to. All right? But a pair of angles whose degree measures have a sum of 90 degrees are complementary angles, and the cofunctions, sine, cosine, secant, cosecant, tangent, cotangent, those cofunctions assign equal values to complementary angles. So the co actually comes from complementary here. All right, we'll talk about that more in detail when we get into some specifics. All right, I think that's it for angle basics. What is the definition of an acute triangle? Because we can classify triangles two ways, right? A triangle is a polygon that has 3 sides and 3 angles, so we can classify it based on its sides. We can also classify the triangle based on its angles. All right, so what is an acute triangle by definition? All 3 angles must be acute, right, which is less than 90 degrees, greater than 100 degrees. A triangle whose angles are all acute, and that means between 0 and 90 degrees. All right? So if a triangle can be acute, what's the other classification based on angles that we could put on a triangle? It can be obtuse, right? What is the definition of an obtuse triangle? It has what? One obtuse angle. Can a triangle have 2 obtuse angles? No. All right, so an obtuse triangle has exactly one. You really need to put exactly one obtuse angle, because it can't have more than one. You see what I'm saying? Do y'all understand exactly one? If somebody has exactly $1, that means they have exactly $1. But a person that has $2 has $1. You see it? So exactly one means one and only one obtuse angle. It's impossible for a triangle to have more than one obtuse angle because it would be more than 180 degrees. And the final classification is right triangles. And a right triangle is a triangle that has one 90-degree angle. And again, exactly one right angle. Can't have more than one because that wouldn't be a triangle. 2 90-degree angles would be 180 all by itself. All right, so that's the classification of triangles by angles. You can also classify triangles by their sides. Okay? Now, what are the 3 classifications of triangles by side? I've heard you mention one already. Scalene. What is a scalene triangle? No. Scalene triangle has all 3 sides different. All right? So a triangle whose sides all have different lengths. Now, as a side note to this, a triangle that has 3 sides that are all different lengths is also going to have 3 different angles. The angles can't be the same. And this is just kind of a side note, 3 different angles. We're classifying it as scalene, means that no sides have equal lengths. And as a side note to that, a corollary, you would call this in geometry, a corollary to a theorem or a corollary to a definition. The corollary here would be it also has 3 different angles. All right. The second classification is what? You said it earlier. Isosceles, right? An isosceles triangle, and this definition is a little tricky, and there's some kind of disagreement in mathematics about what this definition should be. I like the old version, which is that a triangle with at least 2 congruent sides. At least 2, which means it could also have 3 congruent sides. So a triangle with 2 sides congruent and a triangle with 3 sides congruent could both be classified as isosceles, but we're not going to classify the one with 3 sides. Now, the reason that there's this conflict is because that every equilateral triangle, which is the third one, if a triangle has all 3 sides congruent, it still meets all the special qualities or qualifications of an isosceles triangle. So we can apply the isosceles properties to the equilateral triangle, which means an isosceles triangle is also, an equilateral triangle is also isosceles because it has all the characteristics and qualities of an isosceles triangle. Just like a square is a rhombus. Right? A square is a rhombus because all 4 sides are equal. It's just that a square also is a rectangle, and a rhombus doesn't have to be a rectangle from geometry. So it's that kind of thing. The final classification of triangles based on the number of sides is called an equilateral triangle. Equa means equal. Lateral is all the sides of it. So equal sides, equilateral triangle is a triangle with all 3 sides congruent. And as a corollary to this, oh, hold on, I need to go back. We need to add a little corollary to isosceles triangles. It has 2 congruent sides. It also has 2 congruent angles. Okay? They're called the base angles. 2 congruent sides. Also has 2 congruent angles. Thank you. Not to be confused with angels. Spell check won't catch that one, so I'm sure some PowerPoint somewhere is going to have angels in it instead of angles. It's a Christian school, that's okay. All right, 2 congruent angles, and those are called the base angles. Let's talk a little bit, next to isosceles, let's label an isosceles triangle. Here's the isosceles triangle, and remember in geometry you show that 2 sides are equal by putting the little hash mark there. So there's your 2 congruent sides. Those 2 congruent sides are called legs. So a isosceles triangle has 2 legs, and the bottom is called the base. All right, and these angles are called the base angles because there's the 2 angles on either side of the base. And the base angles of an isosceles triangle are always congruent. They're the sides that are opposite the angles. Not going to be a real important concept for us in trigonometry, but I want you to kind of just recall that from geometry. It is a common ACT thing. You see these properties like this, you'll see pop up on ACT. All right, so the final one is a equilateral triangle. All 3 sides are congruent, which means also all 3 angles are congruent. A special name for this is also called a regular triangle, a regular polygon. A regular triangle or regular polygon has all sides and angles congruent. So we can talk about regular polygons or regular triangles being equilateral. So we can classify triangles based on angles. We can classify triangles based on their lengths of their sides. Okay? Now, a right triangle can be isosceles, right? A right triangle can be scalene. Can a right triangle be equilateral? No, because equilateral triangles have to have 3 congruent angles, which means every angle of an equilateral triangle is equal to what? 60 degrees. Okay, so just kind of keep that in mind. A right triangle can be isosceles or scalene, but a right triangle cannot be equilateral. All right? Now, that is it for today. Pretty easy, right?